Thank you. Good afternoon. You've made it to the final presentation. I was sure when I found the time slot that I'd have 2 people in the audience because they're, but I'm glad to see that there are more people. So just to kind of give a little preface about a couple things. First, remember this is automated cross-site scripting detection. It's not just general cross-site scripting technique. The second thing is that when I wrote the presentation a number of months ago, as I was writing it, as I would come up with ideas, I was like, I got to put this in just in case. And I filled up about 40 some odd slides of material. It's pretty dense. And then when I was reviewing it, I'm like, you know what? I probably put a little too much weeds in, a little too many trees and maybe not enough forest. So I'm going to do some summaries to kind of bridge some of this over. So it comes in a few sections here. Oops, right? And the first section, I'm going to basically go over what's kind of out there now, right? It's going to cover stuff that, maybe you see it running in your environment, maybe you've never seen it before. Some of it's historical. It's more about, what's happened and how this is different than all the kind of stuff that's happened in the past. So if you see some stuff and you're like, I'll focus on kind of probably what you're seeing in the environment. And then the next stage, I'll kind of begin to show how what I'm doing is different. So the state of automated cross-site scripting discovery today is that, for the most part, it's a signature or static-based analysis with payloads. And the 3 kind of most general methods, which I'll go into, are what I kind of nickname the SLAM, the tracing payload. That's the kind of most common way. That's what you're probably seeing today in a lot of the stuff that you have in your environment. And then another method that's out there, like the first one, the last one, aren't really used anymore, but they're historical. The middle one, I actually just put it in the middle more because it has a better flow of trace and then trace and replace. And then basically, we'll briefly go over the issues with using this kind of technique or these kind of techniques that are out there. And then we'll go into differentiating. So have a lot of material in here. So what I'm going to do is I'm going to go fast through and then focus on the slides that are important because this stuff's pretty dense. Hit some demos to show that it's like real and it's not that abstract, and then go into the Q&A. So that's the plan. All right. All right. So the key is that the idea is this is not all the different methods. This is just the most simple to get to communicate the ideas and how the ones are flawed. So here's some history about what happened. Basically, I was using a lot of scanners. I would always find cross-site scripting manually, right? Whether after the automated systems had been running, and I was kind of curious to know why is it that I'm able to find stuff when the scanners aren't. And then basically what really prompted this was Yahoo and around Valentine's Day of 2014. They had a bug bounty program. They announced it on Twitter, and it's like, we're going to double our bounties if you find stuff on our sports.yahoo.com. And, I fired up burp, went out there, and it was like, a few minutes. It was like 10 minutes, and I found a cross-site scripting issue, which I submitted and then further researched and found across about 17 different domains. And I was really curious to know, I was like, listen, Yahoo is pretty big. They have to be running automated scanners. Why isn't these scanners detecting it? Why am I able to figure it out manually? And then basically that's how it came out from there. And this basically led me to the improvement in the methodology. I wrote a quick prototype and to demonstrate it, and then this is basically what's out of it. Let's see here. So this is basically what signature and static analysis is, right? And basically the problems with them. The strings consist of sample exploits. They're fixed syntax. Sometimes these strings contain a unique identifier or tracer value. Sometimes they have callbacks, debugging to be able to validate. The problem is that they can't satisfy a lot of different conditions. It's basically, if it fits, great. If it doesn't fit, well, we can't handle it. And basically, the way I see it from my perspective is these are basically like antivirus signatures to a certain extent. So I put the last one in, and I'm a big fan of OWASP because I'm going to pick on one of their projects a little bit because it's open source. So you can see that in the very popular XSS exploit framework, right? It comes with 4,800, and this number's gone up since I captured this, distinct XSS payloads, right? And they look pretty much like this. Now, there are a lot of them that are a lot more complex in nature, a lot more strings, a lot more encoding, a lot more, but this is the most obvious example of having a string with different, what do you call it, different syntax, but it's basically this very repetitive, the same thing over and over. And if your code doesn't happen to match one of these syntax issues, then it doesn't find it. Here's another example from another open source utility, XSS. Same kind of thing. You can notice that there's a payload, and it kind of gives the browser versions which it may be affecting, those kinds of things, but they're static, right? Same thing with W3AF. I picked the first and the third one because they're pretty well known, right? I mean, if you do pen testing, you probably know about them. And it's the same thing, static payloads, right? So now I'm going to go into the techniques that these scanners use with those payloads. Okay, and for the most part, everything that's out there now is a variation of the three techniques that you're going to see. Those are the ones that I popped up earlier, but we're going to go a little bit more into the logic of it. All right, so this is what I call the payload slam. All right, basically, your scanner goes out, it finds a parameter with a data value, and then it basically just does a quick substitution, slams it in there, does the replace, and tries to identify if there's a vulnerability. All right, there's no tracing value, no callback, nothing. It's one of the methods that's out there. This is the most popular method, the one that you've probably seen in your environment, just to be frank, right? You find a parameter with a data value, it has a payload with a tracer value, it's basically signature based, like you saw before. And then, it sends that to the application, and hopefully you get 1, 2, 3, 4, 5, or whatever your unique identifier is, or your callback, or something like that. And if that works and you find it, then there's probably a vulnerability there. If not, well, it doesn't detect it. Again, this is a more historical one, but it's just for completeness. What it does is, it finds a parameter with a data value. It puts in the tracing value like 1, 2, 3, 4, 5, similar to this payload here, and then some of the tracing value, and then basically submits the payload right after that with no tracing value in the payload. Is that clear? Anyone have any questions on the older methods that are used? All right. So basically the issue is string transformation, right? You submit a string, the application does something with it, it breaks it in some way, you can't, and then the automated scanner can't figure out what to do with it, and then it basically fails, right? So here's where I'm going to provide some context about where I'm going with this, okay? So instead of having a static long string, what we're first going to do, what we're going to do really is trace the data through the application. All right, we're going to find the input and where it comes out. All right, we could sign a tracing value, like a unique token, slug, whatever you want to call it. It's going to go in. We're going to try and get it into the application through a variety of methods. We're going to see where it ends up and see the output and basically create case studies based on that. Now, once we know where it comes in, where it comes out, right? There's nothing special. It's just, a unique alphanumeric string, okay? Once we can map the input to the output, we know where it comes in, we know where it comes out, and we can create our cases, all right? We then can begin testing specific cases. We can then say, listen, does this particular character go through the application? Because I know what this string is supposed to be, right? We're going to put our tracer, we're going to put our character in, we're going to put the tracer behind it. It's going to be a unique string like tracer, character, tracer, and we know that that's unique. We know where it goes in, we know where it should come out because we've already mapped that. And once we do that, we can then determine if that character comes out on the other side. And when we look at where things are out on the other side, right, we look at the source code of the application, whether it's reflected, stored, whatever. you're going to know the context in which those tracer values come up, right? Goes in, I know I'm repetitive, but I just want to try and get the logic clear, right? It goes in, comes out, where it comes out, you're going to know where it is in, let's say, that HTML or JavaScript, whatever. You're going to know whether it's in an attribute. You're going to know if it's between tags, right? You're going to be able to parse that out and figure out more information about it based on that, because you're not worried about any kind of transformation happening, right? I mean, maybe the field doesn't accept alphanumerics, right? Then it's probably not vulnerable anyway. So that's the kind of structure. You're going to get data in, get it out, figure out a unique way of creating unique strings to get it through, and then you can figure out what makes it through and what doesn't make it through. And based on what makes it through and what doesn't make it through, we can build a table, right? And then once we build a table, we can determine our exploits based on the table, because we're going to know what characters can get through, what can't get through. And then that's where the dynamic, one of the areas the dynamicism comes in. We can also, by the way, because we know what the HTML is, right, or the JavaScript, we're going to know what the syntax is. We can parse that stuff out and then create unique exploits based on the syntax which we can analyze. So that's the case. Any questions? That's the broad overview before I start going into some of the weeds, right? So that's the framework. Anyone have a question on the framework? Yeah.
Compare your idea with the BuzzFeed, the way they click scan.
Okay,
You know, BuzzFeed basically scan, automatic scan.
Right.
Basically, you put the special string, like a CR.
Yeah, but they don't test for characters first.
Yeah.
So they can't do more dynamic. They're more like, right? So that's the first thing. But all right, I answered that. Let me just say that I'm not going to answer questions about commercial scanners and things like that, products that are on the market. It's not really right for me to, you know, you can figure out the implications. All right. Okay. So going into the weeds based on the framework. So what we're doing is we're initially going to figure out the characters that we can get through the application. All right. So instead of using these long strings as payloads with tracers, go back to the characters. We can figure out how the application interprets those characters, how it's passed in. We can figure out the filtering rules, and we can narrow our requirements exactly to what the situation calls for. Again, because we're dealing with unique strings that we can track, that's how it gets automated. Okay. The characters in the syntax information help us create something on the fly, essentially, dynamically, especially when it can come down to more complex cases. All right. Let's see. All right, so this is basically about assigning unique slugs to fields, right? It's basically our input. There are a lot of different ways to do it. I actually have, what do you call it? I have algorithms that I have dynamically generated. So if you want to take a particular field and then generate tree values out of that, you want to generate, you know, all different kinds of variations, because different cross-site scripting and the application may behave differently if different parameters are submitted to it and in different ways. But the key is that it's really one slug per field so that you can do the tracing through. Let's see here. All right, so this technique of basically data tracing works in a variety of contexts, okay? I kind of mentioned the filters, that we can figure out what gets through and what doesn't, all right? In terms of reflected cross-site scripting, it works for that. It works for DOM-based, which I will go into a little bit later. I'll give a little proof of concept there. There's something what I want to distinguish. It's a little bit of a fine distinction. I call it in-memory cross-site scripting, and that is normally when we, and of course stored cross-site scripting. When we think of the different types, when we think of reflected, we think basically something that immediately comes back to the browser, right, as reflected. Stored, we think of that which is stored pretty much in a database, which comes at a later point in time. I found cases actually where the data gets stored in the server variables, okay, for a particular session. This happened when I was looking at a shopping cart, and then it comes out on a different page later on. So it's not straight out reflected, it's not stored somewhere, It's kind of like temporarily held in memory, and so I just call that in memory or reflected memory, reflected stored. All right, so this is basically this kind of sandwich method that I described earlier. Okay, you take a character or whatever your string is, you put it between two unique identifiers to create a unique string, and you find out where it ends up on the other side. You can also, because you end up building tables, right? You can test for encoding, and you can test for any type of transformation for the application, which I'll show you, which I'll go into in a little bit. So you can test to see whether one encoding goes into a single quote somewhere later on. The reason why some of this is important is because, especially in the older browsers, they didn't do encoding. They submitted the character straight, whereas modern day ones do. So this is the detection logic. I already described it, but I'll go into it a little bit more. As you can see, it's very weeds-based, very crowded in here. The goal is to determine the characters needed to complete the syntax. Then we can determine the characters and the strings that make it through the application for XSS, and then we can create specific scenarios based on that. So we've got the value, we put a tracer value in, we figure out where it comes out, okay? Then we trace the characters that get through, we see what makes it, we build our cases off that. Thanks. There we go. I'll ham it up for you, you know. Then, you know, based on the characters and the conditions that we build, we essentially create a payload based on that, you know, across a specific exploit. And all this, of course, you see it's dynamic, right? It's different than kind of like reading through a file or having a set bunch of strings, okay? And then from there, once we can pass that through and we can trace all of that, we know there's a vulnerability there. This is just another example of other kinds of things that you can essentially trace through the application. And if anyone's done any pen testing, you know that some of these things break, right? Or anti-cross-site scripting filters, you know, like script with, or any HTML with just like the left bracket, that'll break on a lot of Microsoft stuff, et cetera, et cetera. So the reason I put this in is that there are a lot of different browser vulnerabilities based on the different character sets, and you can end up testing for that. So this is actually from a real-life pen test that I did. And you know, the bracket didn't work, the %3C did not work, but for whatever reason, I mean, I didn't get to inspect the filter, %3C worked. Okay. But since we're generating this stuff dynamically, we could actually put that into the scanner and be like, hey, listen, you know what? We're creating this table, and I need a rule that does the translation. So whatever character I have, I want a URL encoded and add an extra % sign. And then we can trace for all that and see what makes it through and what doesn't. Same thing kind of in the second case, another real life example. This one, the rules are pretty clear about how they went. You know, you submitted JavaScript, it filtered out. You submit a single character, a single quote, it filtered out. But the way they had their rules set up, they would first check the word JavaScript, and then they would filter out and take out the single quote. So if you submitted, you know, Java single quote script, what happens? It says first, the filter first said, oh, you know what? JavaScript with a single quote doesn't match JavaScript, so we can let that pass. And you know what? There's a single quote in here. That's a bad character, so we got to remove that. And the next thing you know, you end up with JavaScript into the application. And if you know that rule, you know, you can essentially test for that with the methodology, because you're going to be able to figure out what the input is, and then you'll know what the output is, at least in the initial case, and then you could build cases around that. So I'll say that hopefully it's kind of self-evident why this would be more accurate than what's out there now. You know, so let me just see how I'm doing on time here. Okay, 3:20, good. We're doing all right. Browser considerations, I kind of spoke about that a little bit earlier with the different characters. You know, different exploits work in different browsers because the way the characters are. And so, you know, what you can do is you can say, all right, you know, this string needs to be transformed into this to be submitted, and then figure out what the different browsers, the different browsers that would be vulnerable to the particular application. So key takeaways, We're no longer doing kind of like blind submission with callbacks or tracer values in the payloads and hoping that the strings work, because we kind of already know what's going to work before we do it. We can figure out the filter and how things transform. We can see the characters that make it through. We can see the syntax. And basically, this kind of methodology is not technology dependent. That's the last point there. So the practice of it, I kind of covered this a little bit already in the framework, but I'll just review it again. Basically, the idea is that you're going to find the input and the output, right? So what you want to do is submit something and then scan for it and see where it comes out. And that's the technique here, input and output, right? Some of the interesting cases is, of course, you could submit something once and the page which it comes out, there could be many relationships, many different pieces of HTML or JavaScript that it ends up in. It's an interesting kind of case to work on. It can work, of course, for different techniques, get, post. You could use this in headers. You could use it in cookies to test because it's kind of syntax independent. You can parse other kinds of stuff as well if you're interested in those. You can use a technique for that. And it can also be done in DOM. And this is kind of unique. Someone told me earlier over the last 2 days that this is not possible, but then, of course, I showed them that it was possible. And the way this works is slightly different, right? So if you have an automated app that's doing this stuff, if you want to look at the DOM, you're going to essentially need to create a browser object of some type in an automated fashion, okay? So create the browser object. You get the HTML and the JavaScript into the browser, and it renders, in memory. Then what you can do is you can inject custom JavaScript into that page. And basically, once you do that, you have full access to the DOM. All right? Once you have full access to DOM, you could, of course, go and search for different objects and strings and values and stuff like that through there. So you can use the method that I just described, because you first have your tracer value, right? That gets represented in the DOM. You inject your own JavaScript code to search through the DOM, and you find where that value is in what variables. And then, of course, you can then use that sandwich method that I described to see what else makes it through. Does that make sense? Does anyone have any questions on that? I am glad that I am so clear on this stuff. I must be an awesome presenter. Thank you. All right. So this is something else. It's just a little bit more technique of some of the things that I described. Mainly, oh, okay. Who? You. Do me a favor, just clarify exactly how you're defining dynamic. And you mean like where objects change what's in the DOM in runtime, that kind of stuff? Or is it like, what do you mean by static and dynamic? I mean, right now, based on, I'll just say what I'm describing in the presentation, right? What I'm describing in the presentation. It doesn't do things like AJAX, right? But if you had, I'm going to put it more in theory now as opposed to practice, right? If you inject custom JavaScript into a page and you have access to the DOM, you should be able to manipulate it and do whatever you want to it, right? So even though I don't describe anything like that in here, that's a little bit, removed. What I'm talking about is basically figuring out where your data gets assigned within the DOM, and then figuring out what characters get through there. And so if there's something like a document.write, let's say, you can see you can know for sure that that's going to be exploitable using this technique. So. Let's see here. Okay. I feel like I'm getting very repetitive now that I kind of gave the large overview. How am I doing on slides here? All right, so this is an example of what I was describing earlier of building the logic behind building a dynamic payload, a dynamic exploit, which is, essentially once you have the characters, The payload is based on what gets through your table, and then you have the final result. And then this is another example of pretty much the same kind of thing. And I have an interesting way of doing validation, which I'll describe in a minute, which doesn't depend on callbacks, and it doesn't depend on event alerts, event triggers, rather. This is just another example of basically writing a custom exploit based on the characters that we find through there. All right, so before we get to any kind of Q&A, let me show a demo of some of this stuff in action, because it probably looks like a lot of vaporware right now. And by the way, this is the most risky part of this presentation, because you know demos always go wrong. Always. All right. Fingers crossed. There we go. Now I'm going to shrink this up a little bit, but I can make it larger. It's just so you can get an idea of what this looks like. All right. So we're going to go through a little bit of it here. So this is our basic case study, right? It says where we find the URL that we find, the test string that we're using, the test URL, the method that we're using, the unique identifier, the slug that we're using. Are we authenticated or not? We're using a GET request in this case. This is the actual request that's being made. And when we spidered where the data was actually found, it was found in the context of an HTML attribute. I'm going to talk about something which I don't think it gets discussed much, which is testing for XSS privilege escalation. Is it reflected stored? Is it in that server variable case? It's not in this case. Is it reflected? Yes, because it's a very simple example. Is it stored? No. This is the HTML that we find it in. Here are all the characters to get through. There's a table, right? And here are some exploits that make it and the proper syntax for them. So you can note the kind of. Yes. I want to show a little bit of a validation here, which is, I think, unique. Boy, I'm telling you, I'm speaking a lot faster than I expected. I put 42 slides together because I figured I'll definitely have plenty of time. Like, there's no way I can go through all that material, right? And I guess I'm a little bit fast. I think it's the caffeine, to be quite frank with you. I'm a little nervous, just a little bit. So, yeah, I'll zoom in a little bit, especially in this case. What? Hopefully this, there we go. See if that fits. So here's the validation case that I'm talking about, all right? So normally the way it works is that you have callback to another spot, right? Or you're waiting for an event to trigger, okay? In this particular case, right, what we can do is instead of using either of those, which are kind of dependent on other things, if data is assigned to a variable, right, by nature that code is executed by definition, right? So we don't have to rely on something external. All we need to do, right, is inject into the page that we're having in the browser, our object, check to see if that known variable, right, has the value that we assign to it, and if it does, then we know that that JavaScript has executed. Does that make sense? Anyone have any questions on that? So basically, it's a different way of doing the validation. We don't need any kind of external thing. We could simply read through the DOM and figure out if the data has been assigned to a particular variable. These are just other examples of different contexts which we're pulling from. You guys want to see the DOM example now? That's the most risky one for me. and then I'll answer questions. All right, so here's a piece of HTML, right? Totally DOM-based. It is the worst piece of JavaScript and HTML probably I've ever written. It's just an example. You have this vulnerable function, DOM XSS. It takes in a string. It then assigns that string to like 3 different variables just to show that I can search for them and then show that the value that's in them after the assignments. And then it does the document.write. Pretty straightforward. This is the unique slug value, right, that I've been talking about that was assigned in the other examples to the field. This is commented out. We're going to go into that in a second. That's basically the validation piece of it. This is just an alert that we're going to run to show that basically it's DOM-based XSS, and then boom, that's what it looks like. It gets triggered on the onload event. Let's see if I can. Boom, there it is, right? Pretty straightforward. Not good. This is like what's feared most. So let me just put it 0. So the next thing we're going to do is we're going to take this out. Just comment this out. Right. And basically, to show that it works, this exploit success variable should be set to that number, which I have in this example here. Right? Now, I'll just say, because I don't want to show some of the code that's behind the techniques, it's a bash shell that basically submits the value to another script that does this behind the scenes. I promise you, it is not grep or it is not regex or something like that. All right? Which is probably why I made it so obscure. Okay, so when we run it, it shows that basically it shows the technique of injecting JavaScript into the browser, our custom routines, and then searching through, right? And these are all the JavaScript-based objects, DOM-based objects, and the values that they're set to. All right. Let's go back to here. Okay, so now we'll do the Q&A. It's a little bit shorter than I expected. Sorry. You have a question? Okay. I wasn't sure if it was that or you were leaving, because I had a lot of exits. Well, a few. They're catching planes, I'm sure.
The work that you've done and the exploits you've seen, do you think that browser companies should deploy XSS detection tools, or do you think it's a losing game?
Do I have to answer that? No, I mean, look, security is basically an arms race, right? So any mechanism that gets built, someone's going to try and defeat it, and then once it gets defeated, someone's going to come up with a new defense mechanism, and it's going to keep going back and forth. So I'm for more protection mechanisms than less, obviously, because you want things to be safe. But there's no guarantee, if that makes sense too. You're welcome.
So this is about the DOM XSS example by issue.
Yeah.
So I may be wrong, but I was just wondering that looked more like reflected XSS because the variable is being populated on the fly. The response just populates whatever is being injected.
It's not, okay, so let me exit out of here for a second. I'll go back. That's why I tried to carefully construct this example to show that it's not reflected, because So first off, you can see that that there's no point in which there's a script value that's like in the page. Let's see here. It's not reflected because when I open this page up, right, I don't have a parameter on it,
It's populated into a single line document of right,
right?
but initially in JavaScript context, it's being incorporated inside a variable, right? So we have an XSS right at that point. I mean, that look more like reflected XSS.
Well, usually reflected XSS is when the value in the variable goes directly out to the written to the page.
So in this example, what you mean is directly on the page, because it's the HTML has the JavaScript inline script with the variable, and it has the input value variable. Is that right?
Right. Well, look, I'll put it this way. Even if you don't like the example that I gave you, okay? And this is still reading through the DOM and all the values in the DOM for specific values. How's that? Is that fair enough? Even if you don't like my example, the technique is still valid, and this shows that, you know, you can read through it and you can find a variable that's set to a particular value that's controlled by the attacker, both the variable and the input to that variable.
Just want to clarify. I was missing.
That's fine. You know, you can buy me beer later and we can talk about it. All right, what's up?
I was kind of curious, you know, a lot of the times when you're spinning kind of your standard polyglot payload or something like that, you know, you can limit that to a relatively small number of payloads since you're using something that works in multiple cases.
Right.
But here you're going to end up, I would assume, submitting a much larger number of requests. Is your number significantly higher to the point where you might actually cause some issues in terms of load or detection, or is it relatively small in terms of your characters that you're submitting?
Right. That's a great question. So, of course, the correct answer is it depends on. So, on one hand, depending upon how you're going to run it, it could be a lot faster, right? You only have to check, let's say, in particular context, if double quote or single quote gets through. Doesn't, done. We don't need anything else. So right there, you save X number of requests over X number of trials, right? But if you're going to decide, you know what, we're going to run for specific cases, we're going to try and find this really obscure stuff, and we got to generate a lot of weird data to do it, then you're generating. So, you know, it's a trade-off, right?
No, that's totally fine. I'm curious. And then I have one more on that one. All right.
That's all right. I finished early, and I'm very popular.
But in something where I guess they're being called delayed XSS now, or whatever you want to call it, where somebody is submitted an application but doesn't necessarily get reflected in that application, and maybe in like a log monitor somewhere else.
Right.
Where those are only kind of registered through a callback or something like that. Is there a way that you found to kind of utilize a technique like this by looking at like 2 callbacks, or
Well,
have you looked at something like that?
Well, I'll say this. The method I described doesn't exclude using callbacks, right? Callbacks is just a technique that you put in your payloads, right? So as long as you know that those set of characters and stuff can get through, and that callback can get through, then wherever it ends up, you can find it at a later time.
A single character listening for that, and then it's
Well, I mean, it all depends on how the application is built, right? I mean, you're discussing a case in which essentially it's totally blind, right? So you're going to have no feedback at all.
Also, the feedback would be your listener that you have remotely somewhere else.
No, what I'm saying is, yeah, yes, if you're using callback methods and just blindly submitting strings, then keeping your fingers crossed you're going to get something later on. You know, I mean, yeah, no, it's all right. It's an interesting case, but you know what I'm going to say is that, you know, you're not going to see improvements in any method because it's what gets resulted is totally blind, and it's basically luck.
Okay, cool, thanks.
Yeah, no problem.
I checked your website and you mentioned that you found
Which one?
software.
Oh, okay, yeah.
And you mentioned that you found some XSS vulnerabilities in a couple big sites like GitHub and OpenCube and so on. Were any of those start XSS, and how long did it take for your score to find those, and how many requests did it take?
Wow.
Ballpark.
Okay. So first, let me try and think through the ones that I've done. So the one on Yahoo was reflected. The one on OkCupid was reflected. The one, which of the other one? The one on Yandex was also reflected. The one, I'm trying to think of the other one. I have another one somewhere, but I can't, you know, I don't have a history of my, so, you know, I'm sorry?
I definitely see how you could find startups as this.
Yeah, I mean, I could talk about sort XSS. Actually, I think this method is definitely superior in finding it, right? Because you know where it comes in, where it comes out. In terms of the requests, I mean, it's pretty fast. I mean, you know, a lot of it was standard kind of stuff that they somehow overlooked. I was actually sitting next to the guy from Yandex when I found that one, and he's like, he's Russian. He's like, it was an older server.
All right, awesome, thanks.
Cool. Anyone else? Questions, comments? Thank you very much.